Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, we have an informative topic for you today. Here it is. Connecting AC inputs to Horner OCS. Well, as control engineers, a vast majority of what we deal with are DC signals, and for good reason. DC is safer, it's easier to deal with, and it's also much easier to get machine certifications if our systems are based on DC. But how do we deal with AC signals on those occasions where that's needed? Well, today I'm going to show you how to do that with the Horner OCS all-in-one controller that appears on the surface to only support DC inputs. Okay, so without any further hesitation, let's break down today's topic. Okay, we're going to start by answering the question, why AC inputs in 2025? Then we're going to give you some AC input examples, and then we're going to show you how to integrate AC inputs with the I/O that's built in to the Horner OCS all-in-one controllers that appears to be DC only. How are we going to do that? Then we're going to show you how to connect AC inputs to OCS-I, that's Horner's expansion I/O system. And there'll be plenty of demonstrations throughout. Here we go. Okay, so why AC inputs in 2025? Well, we talked in the open about all the good reasons why we use DC on a regular basis. However, sometimes we have projects like a machine retrofit where there might be legacy AC sensors and the decision may have been made to leave those sensors in place. If that's the case, then we need to deal with those AC signals that are being put out by those sensors. Okay, so how are we going to do that? Well, first, let's take a look at a couple of different scenarios where we're dealing with AC, starting with those legacy sensors. So on the screen there, I have an example inductive prox. That is an AC-only inductive prox. Now these days, most inductive proxes support either AC or DC. However, there's plenty of legacy sensors that were AC only, and we need to be able to interface with those. Another scenario where we're dealing with AC is where we have maybe a series of circuit breakers, and we want to tap into the wiring after the circuit breaker so we can detect whether we have voltage flowing through that wire or not, or current flowing through that wire, I guess would be more properly said. Okay, so that's another scenario, the output of a circuit breaker, where we might want to tap into an AC signal and be able to interface that with our control system. So these are just a couple of different scenarios. Now we get into the how. All right, so when we have a Horner OCS with built-in I/O and it's all DC inputs, how do we connect those AC inputs in that scenario? Well, it's very simple. We use a device called an Optoisolator. Now, an Optoisolator is a compact DIN rail mounted device which effectively completely isolates an AC input signal from the DC input circuitry built into a Horner OCS and converts that AC signal over to DC. You simply use one Optoisolator per AC input, and then you can mix and match between DC input signals and AC input signals, simply putting the Optoisolator in between any AC input and one of the DC input terminals. So they're really convenient components. Now you can acquire them from a number of different locations. Now at Horner, we do have an Optoisolator that we sell on our website, but you can get them from your local distributor. You know, there's nothing special about the one that we offer. It's certainly not one that we manufacture. You can get them from companies like Murr and Phoenix and others. But anyway, for interfacing an AC input signal with a DC only input circuit, these are the way to go. Another advantage to the Optoisolator is that they support voltages all the way up to 240 volts AC. So if you're using higher voltages like that, you're almost certainly going to need to use an Optoisolator. A while back, I did a demo of using an Optoisolator with a micro OCS's built-in I/O. And that would apply whether we're talking about XL Prime or Canvas or any Horner OCS with built-in I/O. It would also apply maybe to let's say Smart Rail I/O or Smart Block I/O or any other DC only Horner system. But let's take a look at this demo in the Wayback Machine of an Optoisolator connected to the micro OCS. This is one of these Optoisolator devices. Here's the AC side. This is where we would connect our AC signal that we want to detect or sense, if you will. This terminal, the A2 terminal, that's where we're going to connect the neutral as the reference for A1. Of course, you have optical isolation here in the center. And then this is our DC side, okay, with the positive output pin here and the common output pin. So I've actually wired this guy up. So there's one right here, okay, and I'm using this circuit breaker here with a manual switch on it to kind of switch an AC signal. So we've got a hot signal running into the top of the circuit breaker, running down the circuit breaker and into the Optoisolator. We've got neutral coming into the Optoisolator as well. On the other side, we've got our DC connections, and then coming out of our DC connections on the other side of the Optoisolator, we have this orange wire here that's wired into a digital input on the micro OCS. In this case, it happens to be I1. So if we take a quick look at this screen here, you can see we don't have any power happening here, or the voltage is off effectively. So if I turn on the breaker, you can see I get an indication both on the physical device itself, on the Optoisolator itself, and then I've also got, of course, the micro OCS sees that as a 1. Now the beauty of these devices is that you basically use 1 per AC input that you have. So if you've got, let's say you've got 3 AC inputs total in your system, you would use 3 of these Optoisolators, and they're not all that expensive, frankly, and then the rest of your inputs are still available for standard DC type inputs. Okay, next we're going to take a look at that scenario where we want to connect those AC signals to external I/O, in this case, Horner's OCS-I. Now, if you're not familiar with OCS-I, OCS-I is Horner's newest expansion I/O system. It mounts on DIN rail, and it just so happens that there is an AC input module available for OCS-I. So the way you integrate OCS-I is you start with a base, and there are 2 different bases available. One base that strictly provides the connection to your OCS with no built-in I/O of its own, and another base component which offers not only the connection back to the OCS, but also offers a little bit of built-in I/O. And then once you've started with your base component, you can add either 7 or 8 extra I/O modules per base, and you can have up to 16 bases per system. So it's a very scalable system. So again, one of the beauties of OCS-I, besides its variety of DC input and relay output and analog type modules, is it does support an AC input module, and that's what we're talking about today. So let's take a closer look at the DIM620, HE959 DIM620, which is the AC input module that provides 8 AC inputs. Now, it supports voltages up to 120 volts. So if you have voltages higher than that, you will need to use an Optoisolator. But you've got your 8 inputs. You've got a place to connect your L2 or your common type connection there. And it's really easy to integrate. Once again, it is limited to 120 volts AC. So keep that in mind. All right, but that's a majority of what the applications are anyway. And again, the wiring was quite simple. On the L1 side of things, you run that through the switch and then into the input. And on the L2 side of things, you run that into the common terminal. Okay. Now, all common terminals are on the same potential. So if you have multiple phases involved in your application, you'll have to have 1 module per phase because of that. Okay, now it's time to demonstrate AC signals with OCS-I. Okay, here is our Cscape 10 program that I'm using to demonstrate connecting AC inputs to OCS-I-O. And let's start off in the hardware configuration because that's where you will find OCS-I-O. Okay, so my demo system here is based on an XLW Prime OCS all-in-one controller, and it's connected to OCS-I-O over C-scan. All right. Okay, so what we have here is a very simple 2-module system where the first module is the base, happens to be the base with built-in I/O, and the second module is one of our 8-channel or 8-point AC input cards. All right, let's take a look at the configuration of the base. All right, so I gave the base a convenient name, assigned some status variables to it, and then I needed to allocate a place for the I/O to be mapped in the Horner memory structure. Now, when you're doing this, you're typically going to use, like I have, some I/O arrays that have been pre-configured in Cscape. And there's an I array, a Q array, an AI array, and an AQ array. Now remember, because these are arrays, they typically start at 0. And the reason that I've allocated them all to start at 64 for this particular base is because my particular XLW Prime has I/O built into it, and I want to make sure that the I/O on the OCS-I/O base is mapped to a location well above the built-in I/O. And then one last note here, and that is this: the arrays, being 0-based, are offset by 1 from the %I, %Q, %AI, and %AQ memory addresses. So I64 correlates to %I65. Also, because there is onboard I/O on this particular base, our AC inputs are not going to be starting right at the beginning of the memory for the base. But to see where the DIMM620 module is mapped from an input standpoint, we can go to the More Info button here, and it tells us for our DIMM620 that those inputs start at I80 on the array side, which correlates to %I81 on the memory side. Okay, so that's our OCS-I/O configuration. And then I could have just chosen to use I80 through I87 array, input array, directly to map to variables. But instead of doing that, I went ahead and created some separate variables called AC input 1 through AC input 8. And I went ahead and manually mapped those where the AC inputs are mapped with OCS-I/O, and that is starting at I80 on the array side or %I81 on the memory location side. Okay, and then all I've done here is I've created a single screen with LED indications showing the status of the inputs. All right, so let's take a look at the system on the bench. What I have here is I have L1 and L2, or hot and neutral, running to my terminal strip. Okay, the L1 signal, or hot, as we sometimes call it, is running through this circuit breaker. All right, and then the other side of the circuit breaker is connected to I8 on the terminal here of the DIMM620. And then the L2 signal, or sometimes called neutral, is this blue wire here, and it's connected directly to the common terminal, or one of the common terminals on the DIMM620. All right, so that's really all there is to the wiring of the system. We can see here on the screen, everything appears to be off. If I flip this breaker, sure enough, we get our LED to turn on. We went ahead and had another LED indicator here to indicate we have power flow there. And you can see up here in this corner, we also have LED indication on the module. Okay, so really a simple demonstration for you today. Hopefully you can see that OCS-I/O is a terrific option if you have AC input signals that you need to deal with. Okay, that does it for our program today. Here's a reminder, don't forget to sign up for training in 2025. There's the schedule on the screen. Head to our website to reserve your position today. Okay, trade shows in 2025. You can see we've got a lot of them going on in the first, second, and third quarter of the year. We'd love to see you in person at one of the trade shows. Okay, lots of ways to interact with Horner online, including on our website at hornerautomation.com, on our YouTube channel, and on LinkedIn. All right, next week, we're going to continue our discussion that includes OCS-I by covering the OCS-I relay modules that are available, including a brand new one that was not previously available. Okay. Well, if you haven't subscribed to our channel, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, until we discuss OCS-I and the relay options available, let's all get out there and do some good.